Aloha! Alright, tomorrow is Hawaiian Day or Luau Day or Hawaii Day. So make sure you guys dress up in your favorite coconut bikinis, alright? But you guys, thank you for watching the first two videos, which were 8 minutes long. Not me, but this one is me. So it's a little bit better. Alright, but we're going to finish with a little bit more examples. The sub should have given you a packet of these notes along with the coordinate plane of polar coordinates, okay? Make sure you beg for it if you have not received it yet. So let's actually go ahead and graph R for sine theta, okay? R for sine theta. Let's just think about this graph, R value analysis, as we've been doing in the other videos. Alright, for sine theta, so you know that one period is 2 pi. So we're going to graph from 0 theta to 2 pi, okay? Alright, so you guys, I've already graphed that here, 0. Remember sine? Amplitude is 4, so we have our max here, right? We have our 0, we have our 0 here, we have our mid, and we have our 0. So let's actually mark that on this table. You don't have to do this every time. You'll see how I'm going to shorten it later, okay? So 0, 0, right? So 0, 0. Pi over 2 is your max, right? This is your 0, okay? Let's go here. Pi. Pi is another 0, right? And you have 2 pi, which is another 0, which completes our period, okay? And I'm going to label these points as A, B, and this one P, okay? The 0 as a P. And we're going to graph this one as C, D. And you'll see what I mean why I'm doing this, okay? And that's enough. All right, so let's actually go ahead and mark pi over 2. Pi over 2 is significant, and it's because it's 4. So write that. All right, let's fill in the other ones that we know. 0, we know it's 0. And this one is already 2. So these are all, and these make sense, right? You can actually go on here. And remember, this guy is theta. This is your radius. Your y is your radius. Your x value is your theta. All right? And this is called an R value analysis. You're not required to draw a graph of sine or cosine every time, though, okay? But this, I just like to show it to you. Now, pi over 6, you can even look here to see it, okay? But you don't need to. If you want to just calculate it, you can plug it into this equation too. Sine of pi over 6 is half times 4 is 2. So we're going to write that here. And you can see it here too. See, 2 right here. Pi over 3, it's 2 root 3. You can calculate these values on your own, okay? 2 root 3. 2 pi over 3 is 2 root 3. Okay, 5 pi over 6 is 2, and these values here. And you can see how they sort of repeat, right? You can kind of see the resemblance, okay? And I'll explain that to you later. And you guys, we're going to actually graph this onto this polar coordinate, all right? And remember, this is 0, this is pi over 2, this is pi over 6, this is pi over pi over 3, all right? Always fill this in if you need to. And this is 5 pi over 6. And remember, just these grow by pi over 6, pi over 6, pi over 6. They all grow at pi over 6. And then the rest, okay? If you need to, just fill in all the way. And especially for the first ones, I'll show you more exactly, okay? Sorry, this is 7 pi over 6. 7 pi over 6. This is 4 pi over 3. This is 5 pi over 3. 11 pi over, sorry about that. 11 pi over 6, right? Okay, good. We're going to use all this later, but let's actually look at this and graph this. We have 0, 0. Can you see that? 0, 0. 0, 0 is here. You go you rotate nothing, and you go nowhere. And that's P. I'm going to label that, okay? Pi over 6. Pi over 6 is 2, right? It's 2, so you go 1, 2 radius, okay? Pi over 3, 2 root 3. These are coordinates, okay? Pi over 3 and 2 root 3. 2. And then you go root 3. Now this is about, I found the calculator, 3.464. And you know what, you guys? You could go here, pi over 3. Isn't pi root 3 somewhere over here? So you know it's somewhere along this right here. So it's going to be about 3.463. So it's going to go 1, 2, 3.463. So right here. And then it's 4. So pi over 2, and it's 1, 2, 3, 4. So you guys, look at the pattern. Isn't it here P, and then you went A, and then you went B, and then you went C? So what I want you to do is I want you to follow this pattern, the way it was moving from A to C. And I want you to put arrows to know the orientation that it's moving at. It's moving at a path, okay? It's moving at a path. And you can see what's happening here. And if you go on the other side here, look what happens. This is really cool. 2 root 3, it's 2 root 3. So 2 root 3, oh, it's about 3.1. It's about, oh, it's symmetric about that. And 5.5 pi over 6 is 2, so it's right here. 1, 2. And then you can see here pi 0 is back to here. So let's mark that. D and E, and then it goes back to 0, right? So I'm going to put up P prime. This is P prime. You know why? Because it's a point that's repeated. So then what I'm going to do is I'm going to trace that guy all the way. and put arrows. Put arrows. There's a reason why I put the points A, B, C, D, and also the arrows. It's telling you the orientation that it's moving in, but it's also telling you in which order. It goes from here to here, here to here, 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 all the way around until it creates a circle. All right, it's actually a circle. And let's actually kind of see if we're right, okay? So you should have got a circle. So this R, 4 sine theta, it looks so fancy, but it's actually just a circle. So let's see how, now this, you can look at this example, see this, but remember another way that we did it in class is this. If we have this, we can actually multiply the whole quantity by R, right? Then we get 4r sine theta. Oh, whoa, whoa, whoa! Isn't that actually y? So it's actually x squared minus y squared. Oh, x squared minus y squared, right? Oh, sorry, I was right. So I don't know what I'm talking about. Equals 4y. And you remember this? It's x squared plus y squared minus 4y equals 0, right? So you guys, it isn't a equal to c, so we know that this is a circle. And we know if we simplify this, we get this right here. Completing the square, and we get the center as 0, 2. 0, 2 is right here, the center, and you can see that this is a circle of radius 2. Make sure you understand that. Slow it down if you have to. And you guys, I want you to notice a couple things, okay? Now we're going to talk about symmetry, which is it's not really absolutely required that you know what symmetry is, but I'm going to show you a couple things about it, and you're going to have to do a little practice on it, all right? But you guys, in example 1, what you notice after pi, is that the points actually repeat again. Also, you notice that the graph is what? Let's fill in the blanks here. Symmetric. Symmetric with respect to the line. What line? Right here. Pi over 2. Okay? But you guys, let's actually try to think about this, okay? 7 pi over 6. Go back to this one. 7 pi over 6 is right here. It's negative 2 though. So you go here, but it's negative 2. So remember, along this line here, you go back. Negative 2. That's why it goes back to here. So you see how this guy, if I name this guy as F, right? This guy would be actually F2. Do you see that? Because it goes back. Same thing with 3 pi over 2. It's P, right? So it's P. So it's negative 4. 1, 2, 3, 4. But we have to go, remember it's up 4, but it's, It's negative 4, but it's negative 4. So it goes back up to C. So it's actually C prime. Do you see what's happening? Make sure you understand that, okay? So you guys, let's go back to symmetry. There are 3 types of symmetry. And symmetry is actually really formulaic, so I'm not going to require you that you sort of like memorize this, but you should be able to show it, okay? And you should, it's good that if you know it. All right, so you guys, symmetric. Now, this one is symmetric with respect to theta equals pi over 2. And you can see that, right? If it goes from here to here, this guy here, it just gets reflected about the pi over 2 line. Okay? And how does the coordinates change? It goes like this. R is theta. That's how you start. And there's negative theta, R pi minus theta. And these are really formulaic, so you'll see what we're going to do in a second, okay? This guy here, isn't it symmetric about the polar axis? Yes, so you write symmetric with respect to the polar axis. Okay, follow along. And this sucker here, he's symmetric with respect to the pole. The pole is this guy, you guys. It's flipped over this way. Okay? Alright. Now, the main ones that we're going to talk about are these 2 here. As you can see, you see how this is a sine graph, and you see how R it was symmetric about the pi over 2 line. So this one is that case. So this one is usually, so I'll summarize this in a sec, but you'll see how this guy is usually the sine. This guy is usually the cosine. All right? And this one is going to be like your R squares, the fancier ones. All right? All right, let's go on to the second page, guys. Stop the video at any time, okay? All right, let's look at the second page. This summarizes this right here, okay? This is a repeat of what we just saw. Now, to test for symmetry for polar coordinates, here's what you do, okay? The graph of polar equation is symmetric with respect to the following if the given substitution yields an equivalent equation. So, for example, if you're trying to prove that something is symmetric about the line theta equals pi over 2, you're going to replace r theta by, ready? R pi minus theta, or negative r negative theta, okay? Now the next one here, the polar axis, if you're trying to prove that this is indeed, so this is what we'll ask you to do. Prove that this is actually symmetric by the polar or the pole or the line. Theta equals pi over 2. So we're going to try to ask you that. All right, so it's r negative theta or negative r pi minus theta. Right? And for the pole, what you're going to do is the RC is the same, pi plus theta, and try to understand these. Look at this. Aren't you guys going from here, this r, and you're going to add a theta to get here, or to pi to get here? So try to make sense. Negative r theta, all right? Okay, so you guys, now, let's draw an example. We're going to use, here it says, use symmetry to sketch the graph of r equals 3 plus 2 cosine theta. So let's test for symmetry first. We're going to test for 3 symmetries, right? The ones that were known. Now, I'm going to just show you one case where it actually fails, but I want you to kind of remember something here. Do you remember that sine theta is actually an odd, sine is actually an odd function? So that means it's equal to, there's cosine theta too, right? And do you remember this? Sine theta is actually, you got to remember that it's odd and even. Okay, sorry. So cosine theta is actually equal to cosine of negative theta. Remember this? You know how cosine goes like that? Okay? You see how they're equal on both sides? Okay?